And so now if we put together something like ethylene or acetylene, right? Then now what we should recognize here is when I go to look at this, okay, my sp hybrid orbitals, I'm going to now have 2 extra electrons left over in p orbitals, right? And so that's given right here. So if I'm looking at this acetylene, then I know I've got an electron here in the sp, and I've got an electron here in the sp. Those form together to make my sigma bond, right, down my internuclear axis. But now I've got an extra electron up here. I've got an extra electron up here. I've got an extra electron up here. And I've got an extra electron up here to form, oops, I drew those 90 degrees. So those should be right here and here, 90 degrees relative to each other, to give me 2 pi bonds and a sigma bond, which we know is the observed bonding. Okay, beautiful. So I'm going to cut that off, and on the very last lecture I'm going to record, this is going to be very quick, and I'm going to walk you through how we do an X, Y, Z coordinate system with valence bond theory. And that's what's going to allow us to create these lovely Mathematica simulations of the hybrid orbitals, which is the subject of part 1 for your Math 8 assignment. Okay, so the next video will be very short, just detailing how we can mechanically go through these equations and create these hybrid orbital superpositions. Okay, folks, I'll see you in the 3rd and final video on valence bond theory.